Hello and welcome back to another episode of Multi-Tech Spec. Today I've got a very exciting one for you. We're going to be showing you some physical equipment in terms of what routers are, switches, what they mean at layer 1, layer 2, layer 3, right? For continuation of our Cisco CCNA course essentially, right? So let's have a look at it. So if we look here, right, you've got my kind of shelf here. This is what you'd see inside of a typical data center. This is a 42U system, and this is a project that I was doing back when I was a little bit younger, a bit more, shall I say it? Well, why not? A bit more piss and vinegar, right? It's an English expression to say that, you know, we're kind of young and, you know, more, and well, enthusiasm and all that kind of stuff, right? So, moving on, we will see that I have a system down here, right? This is a server. This is running pfSense, and pfSense acts as a router in which you have layer 3, layer 4 kind of capabilities. You can do switching, not switching, you can do routing, you can do firewall type capabilities with this, OpenVPN, that sort of stuff, right? But I want to be clear that this is running on a virtual machine because this runs under the hood VMware, okay? And if we look, we can see that we have a NIC here. This is called a network interface card. This is the Intel E810. The Intel E810 allows us to use fiber optics. And these fiber optics are in the form of an SFP. This is called a small SFP, small form factor plug, essentially, right? SFP. Small factor plug, I think it's called. And from there, we have these cables. These cables are called the OC4 cables, right? I think they're called optical connect 4 cables, version 4 cables. And we have one cable here, which is part of an AOC, right? An AOC configuration, as well as these ones down here. So an AOC cable is essentially an optical cable, right, which splits, like this cable over here. This is another AOC cable. If I can get it, there we go. Into 4 different SFPs, right? This goes from here. So if I go to this section, you will see that we have 2 SFP28s inside of my Arista, okay? And that's what causes it to go from 1 to 4, right? Because this is called a split cable. Well, splitting the cable, it's an AOC, so it goes from 100 gigs down into 25 gigs. This is at a fiber optic level because there's a laser inside of here, which does total internal reflection in the cable, so that way it passes all that information in bits. So in other words, all that electric voltage that we talked about the other day into the card, okay? So at layer 1 level, which is physical, so anything that you can touch, right, is considered layer 1 on the OSI model and even on the TCP IP model, right? So it's anything that you can touch, right? So when you walk into a data center, this is the sort of thing that you would see, okay? All physical stuff. So how does that help us? Well, it means that we now have a reference point when it comes to debugging, right? It means that we now have an idea of what the interfaces are that we need in order to connect up to different parts of the equipment in order to do our debugging steps, right? So old school engineers will say you go from layer 1 to 7. Nowadays, they'll say go from the software down, okay? Now, I think most of the time, it's not necessarily going to be a software error, it's more likely going to be a hardware error where somebody just plugged something into the wrong port, right? As opposed to software, because in software you have version control nowadays, which is like Git, your SVN type software. So I won't worry about that too much. But moving on, right, from layer 1 to layer 2, layer 2 is anything that goes, which is stuff like your VLANs, stuff of that nature, right? But it also represents another part from the physical layer to layer 2, right, which is your data link layer, right? It does all the data link stuff, or your data, which is in the form of a NIC. NIC stands for Network Interface Card, which is one that we have here inside of this server. And you'll see that this connects to the switch via a cable. This cable is called the RJ45 cable. And this is how we receive and process data to and from the switch, which is connected to the pfSense router. Yeah? This pfSense router is then connected to a modem, right, which is my Virgin modem, which is in modem mode in order to get internet access. And that's what we would do something like this for, right? If you're in a big office, you may have 50 or 60 computers that you need to do something like PXE for, right, in order to get them up and running. And that's the reason why we would use a switch like this. Okay? So I hope that kind of gives you an idea as to kind of an appreciation as to why we use some of the stuff that we do. Now, if we look a little bit further up, this is more of an old school setup, right? Nowadays, you would kind of go more with, the Arista setup to do layer 2 and layer 3, because this is a layer 3 capable switch, which means that you can do DHCP, BGP, EIGRP, all the stuff that we talked about the other day, right? Inside of this little box here, right? Now, in the old days, you used to have separation of concern. So you used to have physical boxes like these 2901s, right? Physical 2901s, yes, I do have them with the Highwick 2T modules, right? For some of the Cisco labs. These were some of the older labs. And yes, I haven't used them in a very long time, right? But you will see that the console ports have these little blue parts here, right? So in some of the next lessons, what you'll see is that we are able to SSH into these routers as opposed to using console, right? Why do we not want to use console? So at layer 1, you don't want to be using a console port because this is for your initial setup. This is for things like TFTP booting, so you boot the Cisco iOS image in here. I'm not going to worry about that because I no longer have the 10 network, so I'm happy for you to see this. Yeah, so if people saying like, oh, admin Cisco, like, that's a lab username and password, by the way. So this is not connected to my network in any way because this is a separate network, so I don't really care for that. But going on to the main point, we don't use the console port necessarily, or even anymore, I don't think we use it anymore, but essentially the reason why we don't use console is because there are better ways of doing things, like we can now use USB, for example, and then when we use console, it's over RJ45. When we use, I think it's RS232, or probably even a DB connection, a DB5, I think it's a DB5 or a DB9. I do believe it's a DB5. But if we look at the pinout, we have 9 different ports, I think, 9 or 10. It looks like this, very similar to a VGA cable. And this is what you would put on the other end of that USB cable that we were talking about the other day, right? So this is kind of a little bit about how you would go about doing the lab. If you have real kit, you would hook it up into the rack like this. Talked about the other day, and you have these lug nuts here. And there are little kind of, these little kind of screw holes that you get when you get the rack, and you'd put them into here, use your Allen key to tighten them up, and essentially this is how you would have the system kind of inbuilt, really. These are the HWIC cables. Inside of the packet tracer labs, these are the kind of cables that you would use automatically, and then you would load up Cisco iOS into the system, either via SSH or you would use the console port, right? So SSH we would use kind of in this port here, the RJ45, and the reason why we do that is because it's a network-based protocol, right? It's a secure shell to get into these particular bits of equipment, and with that we then operate the system. So what does that look like at the back, right? And then this is another switch. This is a Ubiquiti one, so this is a Ubiquiti router. This is a bit more advanced because this is a version of BIOS as opposed to the older Cisco, which we have here. This is running iOS 14, I believe. I think I updated this to iOS 14. This is iOS 14 stuff. And this is running Ubiquiti. This is a different bit of software. And in here, this is the one that you can program with BIOS-based syntax. So this works with more kind of a JSON-based approach in the output. And it's made for kind of software-defined networking. So this is kind of more that kind of switch. This is a more modern, more modern layer 3 router, I should say, right, which does DHCP and OSPF. So if we go to the back of the system, and I just have to watch my wirings. Oi! we'll see kind of very similar stuff that we saw the other day. You know, just power on and off switches. And then we have our kettle leads, which are in here. These are the full-on kettle leads, on and off switch, you know, as we need. And then we have our other bits of the system, which are, you know, same, on and off, fans, right, already know this. So for the switch that we have here, because this is one of the switches, you'll see that we have a different plug here. So this is the plug that you would use inside of a data center, which is a DC jack, essentially. And this will provide 12 volts and 13 amps. That's a lot of power for a little switch, but you know, this is kind of the sort of thing that you see at an ISP, and they would have this kind of naming convention, you know, MIL, which is kind of the location, the ISP name, if they have an ISP name, and you know, ISP1, for example, which is one of the locations of the ISP, you know, what the kind of use case is for the switch, and you'd have SW, which is switch, basically, you know, like the first switch in the rack. So it might say SW1, SW2, that kind of thing. Okay. So that's kind of the basics. And if I go down to my Arista, you'll see a little bit, it's a little bit more, does one have, oh no, let's go down to the Dell. So you see we have a Dell and an Arista here, okay? And this is what I was talking about with the stack cables. So in some of the older switches, you'll see like the stack cable down here, right? This is called stack cabling. These are basically ports that you stack one on top of the other for the switch to avoid using one port for a VLAN trunk. So in layer 2, you have something called VLAN trunking. And what that means, right, when you have a VLAN trunk, is that you are propagating all the VLANs from one switch to another, okay? That's all it means. So if you think of like access to a highway, and you have an exit, right, and you don't want it's a toll booth. It's more like a toll booth, actually. So if you don't want certain cars visiting the toll booth, right, what you do is you basically set up the toll booth to say, right, okay, I want only Mercedes going this way. I want only, you know, Toyota going another way, that sort of thing, right? So when you do that, that's kind of like segregation inside of the network. So you're kind of having the broadcast being cut off, right, from everybody shouting. So I'll give you another example, actually. That's kind of a bad example. I'll give you another one. So for example, if you're in a room and everyone's shouting, right, you kind of want to segregate people who are shouting altogether and essentially, you know, shut them up. So you take everybody into a different room. You take other people into different rooms, right? But then you say that, you know, you can't go into the other room because you need a key card. So when you have a key card, you can only go into that room, okay? So that's a bit like VLANs, right? You're telling people to kind of just be quiet and go into a certain room because that's called a virtual local area network. That's called a VLAN, and then go from there. So when you're from there, now you kind of want to say, right, okay, I want certain individuals to go into certain places. So you say, okay, keycard red, go into keycard green, go into keycard red. So now you have access to both green and red rooms. And that's what a VLAN trunk is. It's the same sort of thing. It's just you're saying, right, I'm going to truncate all these networks towards a different place, essentially. So that way they have access to different things. And that's basically what it is. So yeah, I mean, I know we're 14 minutes in now. So I'll leave you to process that information. In the next lesson, we're going to be getting those systems fired up and seeing the output in the terminal. All right, appreciate it. I hope you've learned something. And that's layer 1, pretty much in the bag. Only thing that I would need to cover, I think, is timings. So certain cables have different timings, right, in terms of the signaling. So fiber optic works with light. It's going to be a lot quicker and use a little bit less energy than copper, right? Than copper cabling. Why? Because copper cabling is a bit more dense. Therefore, more energy is needed to send the information through the wire. You know? So, you know, because it's not light as well, the timings are slower. Fiber optic, laser, timing is faster, speed of light, right? And in terms of voltage, basically the same, right? Because inside of the cable, you have bits of data going in and out. So, you know, if we look at the system, just for one more reference, right? Because this one is actually, is it working? Well, it is, but it's not working as much as I would like. So there's no flickering, which is a little bit, oh no, it is. It is, it's just on my other side of the NIC. So you would normally see Because the switch is so fast, it doesn't, it's not doing it. So this looks like, oh, a sedentary switch, but I'm telling you it's not. Oh dear, let's have a look. Right, so if you look here, you see these lights down here? So on this system, it's telling me everything is up and running, right? All the 4 cables are connected, but it's so quick that they don't blink, right? Now, if you look at something like, you know, that's just indicating B and C, but like this cable, this one down here, let's have a look. Can I get my camera there? Yes. See this one here, right? This RJ45, and it has like an up arrow there. In a lot of systems, a lot of networks, you'll see like this light blink, and that's indication of the signal being sent and received at the same time. This is TX and RX, right? So TX and RX would look a bit like this, yeah? Or in standard conventional networking, right, you have one for transmission, one for receive, okay? And that's these kind of 2 LEDs here, okay? And even on, let's see if I can get my camera to go the right place here. If I can zoom in a little bit and get the, come on, come on, come on, come on, zoom. Okay, it's having some trouble focusing. Yeah, because of this cable. Just move that cable out of the way. Come on. Okay, there we go. So we've got link and act, right? So we've got different LEDs for the link activity. So those different lights are showing activity as to kind of what's coming in and out of the system, right? And that's indicative of the voltage. So the voltage coming in and out of the system basically tells you the activity, right? Because it shows that the system is now working, right? And why is that? Because it's a reference to the zeros and ones being interpreted by the system, be it a switch, a router, or a PC on the network interface side, okay? So yeah, that's pretty much it for layer 1 and 2. We talked about timings a little bit, right? So a little thing about timings at layer 1 and 2. So you can have timing issues within the switch. So for example, certain I think it's Realtek systems have this problem, whereby you plug in a Realtek NIC into the switch, and it may be, you know, 2.5 gig, but it reduces down to 1 gig. Like, that's generally a timing issue, but you can sort that out by saying, right, okay, you know, I want to set my bandwidth up to 2.5 gigs within the switch, so it always runs at that particular bandwidth, and then, you know, once you have that plugged in to the equipment, it should always work at 2.5 gig, right? And then you can bypass the system for, you can do, what's it called, rapid spanning tree at layer 2. A rapid spanning tree at layer 2 essentially goes from the blocking state into the forwarding state pretty quickly, skipping alternative, I believe that's correct. And when it does that, then what that means is that, you know, it's now pretty quick. Like it reduces the timings, so that way the transmission can go through quicker. So rather than it trying to figure out through auto MDX, okay, you know, is this 1 gig, is this 5 gig, is this 10 gig, is this 100 gig, you know, 2.5 gig or whatever, it's just gonna straight away know because it's already pre-programmed into the switch, which is something that we can take a look at in future lessons. I'll give you an idea of the OC3 type cable, which I have because it looks so similar to the OC4, and what it looks like at the ends. So when you plug in the OC3 or the OC4, you'll end up with something like this. These are the lasers. So this is kind of the laser. There we go. This is what the kind of inside of the OC cable looks like. So these are the connectors, and inside you'll see, well, you won't see, but essentially there are 2 prongs. These 2 prongs are made of either plastic or glass, you know, based upon the inside. Usually they're plastic. And this one is send and receive. So in other words, this is called full duplex, because one part of the cable sends information, one part of the cable receives information, and they can do this synchronously or asynchronously depending on their configuration. Okay, so it means that information can go this way if you're sending information, and then this way if you're receiving information. Okay, based upon kind of what it is. Now with that, you have this, which kind of ejects it and moves it back in, and it just makes a clicking sound when it's inserted. Okay, so that's fiber optics. You know, fairly straightforward, fairly straightforward. It took me a long time to learn fiber optics, I'll tell you that, because I always thought, oh, okay, you know, you need different ones for different purposes. And that's another thing as well. If you're in the field and you're utilizing fiber optic equipment, certain manufacturers will lock their equipment down. So I've seen this happen with, there's one person on the internet who bought some equipment and was trying to run at 40 gig. And unfortunately, the equipment didn't let him do it because the SFP is encoded to run only firmware from that particular manufacturer. So what does that mean? So if you buy Cisco equipment, for example, check that the SFP that you buy is compatible with Cisco equipment and burned in with the software. Or should I say firmware, more precisely. So when it's burned in with the firmware, that means that the system can recognize the network, not the SFP even, not even the network interface card, the SFP. And then once it's recognized the SFP, then you can start the operation to do, your no shut command that we saw the other day, and then start the transmission of data. Okay, 22 minutes.